Okay, the one more reaction is saponification. Okay, I need to make some changes here. Saponification. We're not going to be reacting this with water. Saponification is an ester plus a base. So it's an ester plus a base is going to form the salt, carboxylate salt, plus an alcohol. This is actually pretty similar to hydrolysis. Hydrolysis, you're reacting with water, but here we're taking an ester and we're going to react the ester with something like sodium hydroxide. Okay, look how similar sodium hydroxide is to water. Water is like HOH. Sodium hydroxide is NaOH. You get an OH and you form an alcohol. You get a sodium and you form the sodium salt. So this is saponification. This is the reaction by which classically for years, thousands of years, they've been making soap by this saponification. And a little bit of history, I think Sapon is the name of a Greek or Roman goddess, okay? And I guess as the story goes, at least the way I hear it, the sacrifices would be made to this deity, a burnt offering of like a lamb or something like that. And the fat of the animal would mix with the ashes of the wood. And the wood ash is potassium hydroxide. It's a base. And the rainwater would fall on this thing and they'd see it sudsing. You know, say, hey, what's this? And they realized they could wash in that kind of water and realized that, oh, they're making something that is good for washing. And that is what it is. It's a saponification reaction that was occurring naturally. Well, let's get an example before we go on to that next one. So if we take something like sodium acetate, or no, methyl acetate. We got to start out with an ester plus sodium hydroxide. We're going to get an alcohol over here, methanol. All right, so this portion of the ester is going to go with the OH to form an alcohol. So here's our ester plus sodium hydroxide. We're going to get an alcohol. And we're going to get this carboxylate salt. So what are we going to get? What's left over? This thing and the sodium is what's left over. Sodium acetate. So methyl acetate becomes sodium acetate and methanol. This is saponification. Every time I see that slide that shows this base hydrolysis and I have it written wrong, I say I'm going to change that. I haven't changed it. I need to go ahead and change that slide. So this is saponification. Base hydrolysis. All right, before I show you this next slide, which goes into a little bit more deeper with fairly complicated with the triglyceride, let's do this last reaction. You see saponification? Sometimes it's referred to as base hydrolysis. And I think that's think of it as a reaction of an ester with a base. Because we're not hydrolyzing it, we're reacting with a base. And we're forming a salt and an alcohol. So there we got the same thing, isopropyl benzoate. Okay, let's just change this right here. We're going to react. We got isopropyl benzoate. We're going to react it with sodium hydroxide. All right. I gave the same ester because I wanted you to see in the hydrolysis of an ester and in the saponification of an ester, there's a lot of similarities. There's a lot of similarities. They're not identical, but there's a lot of similarities. All right, so you got isopropyl acetate. No, wait a minute. Isopropyl benzoate. Right? Yeah, isopropyl benzoate plus sodium hydroxide. You still get the same alcohol, don't you? Isopropyl alcohol. What's the difference over here? Take this H out of there, and you get sodium benzoate and isopropyl alcohol. So nothing happened. Everything is the same here. This thing clips off and picks up that OH, like it did from water. Still get the same alcohol. You don't get the carboxylic acid. You get the salt of the carboxylic acid. Sodium benzoate. Okay? All right. That's saponification. All right, now here is an ester. It's a little bit more complicated ester. It's triglyceride, but you can see there's an ester link, a fatty acid linked to this backbone here by an ester linkage. An ester to another fatty acid, an ester link to another fatty acid. Folks, this stuff is floating around in your bloodstream. It's called triglycerides. If you go in and get a blood test and they check your cholesterol, they check your LDL, your HDL, your triglyceride level. They check all those things in your blood. That would be a lipid panel. You're probably not old enough yet to have a lipid panel. I've been paying for them annually for a while. So your LDL, your HDL, this is your ratio. Am I going to live? Well, keep working. Keep your day job. All right? Keep working. So this is triglycerides. So you ask, what you ask is, am I going to live, and can I keep eating Dunkin' Donuts? The doctor says, you are going to live, but you got to quit eating Dunkin' Donuts. All right. So that's a triglyceride. It's a triester. Does that say that anywhere on there? Triester, triglyceride. That's the glycerol backbone. That's where it's getting that name. Chapter 17, which we will be there pretty quickly, is going to focus in on this a little bit more. It's a lipid. It's not soluble in water. It's got all these non-polar tails on it. So even though there's a lot of oxygens up in here, and this loves water, this portion of the triglyceride doesn't like water. So, if you take that, let's make this a little bit bigger. Let's change it. That M is right there. That's M is saying you got a metal, either sodium or potassium. Let's just make that sodium. 3 sodiums. And so you're going to get a sodium there, and a sodium there. These are the soap molecules. The sodium salt of the fatty acids. So you take, you get this lard from beef fat, or you take olive oil, or if you want to make a good soap, you take coconut oil, olive oil, and then some other cheap oil. The coconut oil gives you the suds, the olive oil gives you the moisturizing properties, and the cheap oil makes it economical to make. But it's still in there. So maybe about 30% coconut oil and 10% olive oil and 60% canola oil or some other kind of oil. And you get these molecules, and these are soap molecules. You're getting an alcohol, so this is saponification, but you're getting alcohol with 3 OHs on it because that's what this glycerol is. It's a triol. It's an alcohol with 3 OHs on it. And you get these sodium salts. These are the long chains here. R1, R2, R3 are long chains. And this is how soap works. One end of the molecule loves water. The long tails don't like water. They're hydrophobic. But they love oil. They love oil. So if you got oil on your hands and you put soap on your hands and lather up your hands, what's it doing? The long tails are dissolving into the oil, and the hydrophilic head is carrying it away in the water. It's emulsifying the oil in the water. And that's the action of soap. Okay, one other term to understand is, what do we mean by a phosphate ester? A phosphate ester. Remember, an alcohol plus a carboxylic acid made an ester. Well, we're going to have an alcohol plus phosphoric acid is going to make a phosphate ester. So if we had something like this, this would be a phosphate ester. You don't have to get into naming phosphate esters. You need to recognize them. And see that? That's kind of your ester. Oh. It's kind of your ester, mimicking your ester. There's your normal ester, organic ester. Here's your phosphate ester. And why are these so important? Can I move on to the next slide? No. I asked. You answered. Okay, Autumn said we can move on now. All right. Having a little fun. Okay. What's so important about esters? Here's adenosine triphosphate. Here's your phosphate ester right here. Here's your adenosine or adenine bound to a sugar that is then bound to this triphosphate or ATP. You've heard of ATP. It's what you need for energy. ATP. Your mitochondria pump this stuff out. But they're phosphate esters. And ATP, here's ATP, will get converted to ADP, adenosine diphosphate. So the triphosphate is getting converted to the diphosphate, losing a phosphate, phosphoric acid, and releasing a lot of energy. So that phosphorus-oxygen bond is a high-energy bond. You break that bond, you release a lot of energy, and your body uses that to drive other chemical reactions. Yeah, so that's the importance of phosphate esters. And I think, does this finish chapter 14? Here's a summary of some of the reactions. Maybe not all of them. So you can take an aldehyde, oxidize it, and make a carboxylic acid. You could take a primary alcohol, oxidize it, and make carboxylic acid. Carboxylic acid plus an alcohol, esterification. Carboxylic acid can just simply dissociate in water, dissociation, react with a base, and you get the sodium, or you get the salt of the carboxylic acid. Let me see if it has the ester reaction. Oh, okay. There's a lot of reactions for one chapter. This is a very important summary right here. Let me see if there's any that we're going to cross out. Yes, there are. Pay attention. We're going to cross a couple of these out. Not many. Preparation of carboxylic acids. Primary alcohol. So we'll put a primary alcohol will oxidize to an aldehyde to a carboxylic acid. Dissociation, we did this on the sheet today. Neutralization, we did this on the sheet today. Carboxylic acid plus a base forms a salt and water. Esterification, we're not crossing that one out. Very important. Carboxylic acid plus an alcohol forms an ester plus water. You could be given any carboxylic acid, any alcohol. You should be able to convert it into the appropriate ester and water. So practice that reaction to where just different. You could see we had benzoic acid and ethanol. We could have benzoic acid and isopropyl alcohol. Acid hydrolysis, or just the hydrolysis. Yeah, this is a little confusing, because when you might see this on the exam, it might say give the products of the acid hydrolysis of this ester, and what students do sometimes, they have an ester plus an acid. They put HCl or something, they think of an acid. It's really reacting with water in the presence of an acid. It's an acidic environment. So I just call it hydrolysis of esters. Yes, that's an important one. Saponification, we just went over that. We did not go over this, so we're not going to look at the synthesis of acid chlorides or acid anhydrides. And this reaction right here, I basically want you to just recognize phosphate esters. You don't have to, don't worry about writing out reactions forming phosphate esters. You should kind of be familiar with what a phosphate ester is. So all of these and saponification are the key things you need to concentrate on. All right?